All right, welcome back. We are COMP397 in the winter 2021 semester at Centennial, and it's week 3, part 2 of our broadcast. In the first part, we talked about Blender, how to create models in Blender and texture them, and UV unwrap our textures for the materials. And we brought the model and the material and the texture into Unity, and we're able to bring that into the scene. And so let's go back here and see where we are with it. We're here. And we have our GitHub repo. One thing to note is this, I have to put this up on this Unity thing. This YouTube thing. Let's go back into our lecture, and I'm going to go into, just so that you can follow me along on YouTube as well, go to YouTube recordings, and I'm going to add a new video. Just so that way you can, that's not right. Just so that you can watch it live, as opposed to if you don't want to watch it through Zoom. Okay, so this is part 3, part 1, and part 2. This is lighting in Unity. That was Blender, materials, textures, and UV mapping. Okay, so now that I've opened up my Unity project, here we are in Unity, and what Arthur had said, or sorry, Liam had said, actually both Arthur and Liam said, well, when I open up my project, I didn't see my models. How do I do that? You got to go into scenes, and you got to double click on main. And if you double click on main, it's going to load the main scene with all the models and everything else. If you had it empty, by default, when you download something from GitHub, it doesn't load your scene because it doesn't know your settings, because it doesn't have your library folder, and you need to double click on inside your scenes, double click on main, and it'll pull it up. All right, so this pixel scaling thing. Sorry, Liam. That was in Blender. So in Blender, all I did in Blender was in UV editing mode, right? What I did was here, I created and I'm not sure if you saw this part, where I created each of these islands. These are islands, right? That's kind of what we call them, like little texture islands. And what these relate to is each of the faces on our model. Right, so again, this is the top face. This is, kind of if I look at this part, this is the front face, and this is the right face, and so on. That's what those are, right? So you can see that those are all there. And you can see a sample of our texture, like way in there, and these things are way bigger than our texture sample. If I had a 4K texture, the texture sample would be much larger, right? Right now it's only a 1K texture, and that's why we lose a little bit of resolution when we bring it into Unity, and that's okay, right? But anyways, you can see how the size of our pillar is proportional to the size of each of our, may I do that change? Each of our faces has a proportional representation on the UV map, right, which is the texture map over here. It's got a proportional representation of each of these things, right? And once I've done that, once I've created all of these islands and saved my object, the texture itself will scale according to my object, because it's a one-to-one mapping. So for example, this object here with this face is sampling from the repeatable texture that is basically going all over the place, right? So this bottom corner is sampling from, as an example, if you look at the tile, it's sampling from this right here, right? Right here, this bottom corner sampling from this image or bitmap is that pixel, let's say right in the corner. Let's say, I'm just going to try and show you this really close up. You can see that this pixel maps to this face, and all I'm taking is these pixels and we're mapping them here. You can see that there's a little divot here, and this divot in the stone is right here, and that's why it looks the way it does. And how about this part? Well, that is part of the repeating texture, which is on the other side, right? There's this part. So this part here is this stone right here. Okay, so that's how I did it. And that's how texture mapping works. This is a repeating tileable texture. And so imagine that it keeps on repeating forever in all directions, which is good and bad. If you look at it from far away, sometimes you'll see like this pattern. And the bigger the texture is, if it's a 4K texture, the less the repeating area repeats less if it's a good one. And that's how it works. So that's what I did. And then once I've saved my Blender file, then the texture information and the UV mapping information gets saved with the material. All right, so this material right here, it gets saved. Okay, good. All right, I'm glad that you understand it. Okay, so that's how it was. I'm going to close Blender down because we've already saved the file, and I don't want to mess up the file. So it's gone. Let's work within Unity now. So a couple of things we did last time, and I'm going to kind of hit the highlights first. Before we do lighting, I want to direct you to the little PowerPoint that I put together for you guys. And I talked about something called the built-in render pipeline. There's actually 3 pipelines. The lightweight render pipeline, which is now called the universal render pipeline. Also the almost like the high quality HDRP, high definition render pipeline, which is a different scriptable pipeline, more advanced than this built-in render pipeline. The built-in render pipeline was the old legacy one that Unity uses. And the new ones include additional features. Okay, so right now we're not going to use the new one, we're just using the old one. And all this is it talks about how to light and create shading for the scene. That's what we're doing. And so this topic today is all about lighting and shading. And part of shading and lighting is materials. Materials tell our process, if you will, how to draw stuff. There's different kinds of rendering processes. The most common is something called, or this most simplest is called forward rendering. And the forward rendering pipeline, what ends up happening is, we render the scene with a number of lights, and each light in the scene affects every pixel in the scene. And so the more lights you put in the scene, because each pixel is going to be, the color of each pixel is going to be affected by each of the quote unquote lights in the scene, then it's kind of when it comes to computational load, it's got a higher computational cost than if you only had one light. The more lights you add to the scene, the more computational cost and the more processor intensive it is. A lot of times we do our rendering, we do it on the GPU. So we don't do it on the CPU side. But we need to select that in Unity if we wanted to make it so that it does a different kind of rendering. So forward rendering is the most common type. It only supports X number of lights. However, and you're going to say, well, why do we use forward rendering if it only selects if it only allows a certain amount of lights based on our video card, basically our graphics card? Well, because it also does some things really well. It does transparencies really well, forward rendering, this forward rendering technique that we're using. So there's also something called deferred shading. And deferred shading, what it does, and I actually put it inside, it's also called deferred rendering, deferred shading. Instead of directly, rendering everything, all the lights at the same time, what we do instead is we create a full screen quad. All right, off screen we have in memory a full screen quad. Think about it as an in memory texture that we're creating live every frame. Okay, and what I'm doing there is I do a composite. I take all the lights in the scene, and then what I do is I affect all of the objects in the scene, all of the pixels in the scene with all the lights that I have in the scene. I can have many, many lights, right, as an example. And I render them to the quad, this full screen quad, which is a texture. And then I take that texture and I do another render pass and I, kind of put it on the screen. That's kind of what I'm doing. The great thing about deferred rendering or deferred shading is it's a composite process. So if I'm going to do post-processing effects like bloom, or if I'm going to do blur or any of those kind of things, deferred rendering is, definitely a way of doing it, especially when it comes to our the rendering pipeline. The challenge with deferred rendering, and this is where it's not good, it's not great for semi-transparent objects. And what Unity does instead is it swaps out that process for forward rendering. It kind of goes back to it falls back to the forward rendering pipeline when it comes to drawing things that are transparent, because it has trouble basically taking a look at those or testing each of the pixels to see if I can see through it from an alpha transparency perspective when I have multiple lights in the scene. So why would you want to use deferred shading? If I have many, many lights, hundreds of lights, I'm going to use deferred shading. If I'm going to use remember, it has computational cost involved from a GPU perspective. It's a little bit less performant than forward rendering. Forward rendering is great if you have few lights in the scene and you don't have a lot of objects. If I have a lot of particles in the scene, many particles and many lights, deferred shading is the way to go. And you can switch modes between forward rendering and deferred shading in Unity, no problem. But you can do this more in the not just the built-in render pipeline, but also in the universal rendering pipeline. So I'm just telling you what these things do. I also talk about lighting, and if you think about this, and here's a question I'm going to ask of you when we start looking at the scene at the beginning. The question I have for you is, are there any real lights in the scene? I mean it. Are there real lights? Are we really doing lights? Is it a true light? What do you think, guys? Yes or no? Real light or no? Here's a light. It's in the scene. Here's my directional light. And what do you think? Liam says no. Liam, you're right. Because there is no real lights. Lights are being simulated. I have a 3D object, and what I'm doing is I'm using calculations to simulate what lights would do in real life. That's what I'm doing. And I'm also translating what I'm seeing on a 2D plane. So that's what this really is. Our screen is only 2D. We don't actually have 3D screens, right? We don't have holography, right? Holographics. We're only seeing things in 2D, and we're translating something we're looking at in 2D into 3D, which is what we're doing is we're projecting it. We're projecting it from 2D into a 3D kind of look and feel. So objects that are further away right now, because we're using a projector, projection, right? Perspective projection with our camera. Objects that are far away appear to be smaller. Objects that are closer up appear to be larger. But the reality is they could be the same size, because in real life, if I have an object that's very far away, for example, the CN Tower in Toronto, right? If you're far away from it, it can look very small because of your perspective. Because you're far away, it looks like could be a little dot, right? But as you approach it, it can look bigger and bigger because objects that are closer to you appear larger. That's a perspective projection, right? As an example. And so what we do is we take the pixels that we can see in the scene, and we convert it from a 2D plane into something that looks 3D by making some mathematical calculations so that the objects look like they're in 3D. The same thing goes with lighting. There's different kinds of lights. The one that you see by default in the scene is called a directional light. Think about it as a light with infinite distance that has one simple direction, like the sun or the moon. All right, that's what this thing is. Okay, so that is the the light. And so what that happens is we can draw rays from the light to every object from one angle, and we can make some calculations of where the shadows would land based on the position, the infinite position of this light in the scene. Right now, our directional light, if you notice, right, has a certain angle. And right now the rotation of it is, from a y-axis perspective, -30, and from a rotation on the x-axis, 50. If we wanted this thing to appear like midday, we could change and rotate these objects. So for example, if I said on the x-axis, if I went to 0, right, you can see that it looks like nighttime because it's coming from the side, right? Let's go back to 50. And if I increase this, so if I increase this light, and if I keep moving this, you can see almost like the sun moves in our scene. If I increase the angle, to 90 degrees, as an example, it's almost as if, we're being lit from the top of the sky, or at noon, let's say around when it becomes 90 degrees, right? And if I keep going, right, as an example, and I keep increasing this, you can see that as the shadows lengthen again, the daylight, wanes, as an example, and it becomes darker and darker as the light goes down. This is equivalent to a day-night cycle. And for those people who are doing the day-night cycle, we can imagine that what this would do, right? So you can keep on, moving around to pure darkness. When your light is directly up above, like 360 degrees, completely inverted, you can see it's complete darkness, right? And even the skybox, as an example, in the scene would look a lot different, very dark. Okay, so this is the directional light that's coming from this thing here. So this is the sun. When you think about directional light, I want you to think about the sun in the scene. And as I keep moving it, again, the sun is going to come up slowly, slowly. You can see that this is sunrise. And as it's coming, it's going to keep on rising until the ambient light improves in the scene and it goes back to 50 degrees, right? Which is here. All right, so that's what it looks like. So that is a directional light. Directional light is a light that appears to be at an infinite distance, and you can increase the intensity, of course. So make a really bright day or somewhere else. You can change the color of the light. So this is an option. And so, example, if I want to make it a warmer yellow, let's say, for example, in some places, or if I'm from around, I can do that. That's what you can do with lights. Lights are regular game objects. They have a transform, and they have a special light component. And they're just objects in the scene. There's different kinds of lights. One other light that that's very popular is the point lamp. I can add point lamps to improve lighting in a scene, and I can simulate things like, as an example, a torchlight or a lamp of some kind. For example, if I right-click and if I add a new light, let's add in a point light. All right, here's a point light. I can put the point light anywhere in the scene that I want. Okay, now you got to be understanding how this works. So here's our light in the scene. It's going to be, let's just reset the light so it's at 0, 0, 0, 0. And let's just bring the light up so you can see the effects. So notice it can add to the light in the scene. So it is a blend of what we see in the scene, right? So let's suppose I have an area in the scene that has a torch or some kind of outdoor light for some reason. Let's say it's hanging off this wall. That wall will appear to be brighter, according to the scene. And when you look at the light, this sphere that is representative of the point light is the range that this light is going to, basically start to diffuse, right? So it's going to be like here, and then the intensity is going to go down with an inverse proportion to the distance, right? So the greater the distance, the dimmer it's going to be. The closer into the actual lamp, the brighter it's going to be here in the middle, right? An inverse proportion. And you can change the range. If you don't like this range, to say this range is too big, you can change it so it's closer in. So it only affects lights that are areas that are closer into the scene. And the mode is very important. This is real time. A lot of times we use real-time lights in the scene. The intensity is something that you can increase. So let's say, for example, I make the intensity 5. Then you can see that clearly that is a way brighter light in the scene than we would have had before. Again, in a daylight scene outside, it doesn't make much sense for there to be a bright light here unless there was a fire. And then we would have multiple lights that would kind of turn on and off to simulate the fire and maybe be a different color. Like, for example, maybe it would be an orange color with the light that would flicker. Right, so something like that would flicker around and maybe a little bit random, whatever. So almost like a flickering light, and you can do that programmatically, with a piece of code that changes the color to some random values in the orange and red ranges. It's up to you. Okay, there's other tricks to use. You can also use a moving texture and a bunch of other stuff here as well. But that is a point light. A point light. It generates a light, or it colors the pixels. It changes the color of the pixels within the range of the sphere, okay, by amount of the intensity and how much the indirect multiplier basically controls the indirect light that's being contributed to the scene. So it's direct and indirect light. Indirect light would be things like light bouncing around from objects if they're very reflective. Then you can get more light bouncing back in the scene. Again, you don't want to really monkey with this unless you want to change what the light effect will be. So shadows types. Right now, there's no shadows. I can say that it's going to generate soft shadows, and when I do, it recalculates the shadows in the scene. So you can see that anywhere the light would be effective, right? So it can generate new shadows in the scene based on, notice over here, based on the light intensity. So there's some additional shadows from this light in addition to these shadows here that were generated from the sun. This light here, this shadow here is generated from this light. Okay, again, it doesn't seem as bright. We're using soft shadows, and you can change the quality if you want to here, if you want to make high resolution or low resolution. There's also something called quality settings, which we'll deal with another day. Render mode is important. By default, it's auto. If you make it important, it's going to render this light as one of the primary lights in the scene. So you don't make it important. It's not when it comes to rendering the scene. It may or may not be as the resolution may be lower. It may also not appear properly, especially if there's multiple lights. Culling mask, it says what is being affected by the light. So for example, if I say everything, that's okay. But what if I don't include the ground? If I don't include the ground, that means that the ground is not going to be lit by this light, but everything else will. I want to turn on a light to make it affect a certain object. These have to be turned on for that particular layer. So you can see that that turns on the light again. So you can have lights that affect some things and lights that don't affect other things. All right, so that is a point lamp. Cool. The last kind of light that I want to talk about is a spotlight. There's other ones too. There's also an area light, but we don't really use that often. So let's put in a spotlight instead. So if I add a spotlight, so again, lights, and if I go to spotlight, okay, then you can see that I have a spotlight, and the spotlight, let's put it inside the scene. It looks like it's on the scene, but actually it's not. There's it reset. And let's change the rotation across the x-axis so that it is 90 degrees. It's pointing downwards. And again, notice that if I zoom in, and you see what this looks like from the side, because it's hard for you to visualize, there is the spotlight. And you can see that the spotlight is exactly what it says. It's a cone-like shape. Here's a cone-like shape. It has a range. And this range is how far the spotlight will project from the game object, right? And how bright it is the same as we did before. If I make this intensity something like 5, you can see that it's much brighter as it becomes closer. And as we move the spotlight far away, it becomes dimmer. So again, the same inverse proportional kind of calculation for the spotlight. Spotlights are great for lights that are pointing download, actual spotlights, headlamps for cars, flashlights. If you want to make a flashlight type game where everything is dark and the spotlight is the thing that sees everything, that's what it's really great for. Again, it has a different effect on things. Again, right now it says no shadows. I can kind of select soft shadows or hard shadows. I can also make the rendering mode important. So it's going to render the scene. Now notice we have 3 lights in the scene now that are affecting certain regions. So I have a shadow from this part, this light that's being cast, this little light line down here. That's the shadow from this light. And this area here, the shadows are being wiped out by both this light, and you can see that this shadow here is being wiped out. If I move my light closer to this where the shadow is from the directional lamp, I can wipe a lot of it out, but not all of it. And the reason for this is because of the intensity of the shadow, right? And the amount of light that I'm getting in the scene, and how intense this light is. If I move the light down, obviously it's going to become brighter and brighter until we light up that area of the scene. You're still going to have overlapping shadows. So it kind of can look semi-realistic. But again, those are the 3 types of lights that we normally see. A directional light, which is very common. It acts as our sun. We can also use a spotlight, which is this, and a point light, which is great for things like fire or as torch or lamp. That is kind of in all directions. Point light goes in all directions. Spotlight points down in a cone shape. You can modify the size of and the scale of different things and the rotation. For example, I can increase the scale on the x-axis for different objects that I'm looking at, right? So let's go back to 1 and 1. So here's the spot angle. So again, I can increase the spotlight angle to make it larger. As I make the angle larger, it acts more and more like a point light and less like a spotlight. Sometimes this is really great if you have you want an area to be affected by a particular lamp, and you don't want to have a directional light necessarily. Okay, but you can do the angle there. And then, of course, that takes care of that. And plus the range is what the distance from this light is to the end. So I can half the range, let's say. So there's only affecting that. Anything outside of the range won't be affected. So again, you can increase the angle of the spotlight. And you can use these effects in combination to create a mixed lighting kind of effect. So that is different kinds of lights: spotlight, point light, directional light. The other thing we have to talk about is, just really briefly, the camera, which is in the player's eyes. Right now, the player's eyes looks at a skybox, right? So there's what the scene would look like in render. So if I run the scene now with all these little lights in the scene, it looks a lot different than it did before, right? Here's a bit of a light. There's my point lamp, and this is in real time. You can see there's also a spotlight up here that I have that's lighting up and reflecting on the bricks there, right? So that's what's happening. You can see that the effects of those lights. And there's even some effect of the point lamp over here on this wall. You can see that these pixels here are a little bit more lit than everything else, but it looks really unrealistic how the shadow falls in the bottom, especially this corner here, which looks kind of weird. That's shadow mapping, and that's a whole other challenge to solve with computer graphics. Okay, so that's pretty cool. And let me just X out of here. One thing to note is it says skybox calling mask is everything. Projection is perspective. Field of view axis is vertical. The field of view is 60 degrees. That's what the cameras. We'll talk about cameras next week a little bit more. But one of the things that it does is it talks about rendering path. So notice that it by default uses the graphical settings. I can force it to do forward rendering, or I can force it to do deferred rendering. Deferred rendering, again, remember, transparencies aren't great, but I can have multiple lights in the scene. This is a per camera situation. I can also add it, so if I have multiple cameras, it can look at the scene in different ways. Let's take a look at what it looks like now with a deferred rendering pipeline kind of look. The objects seem a little bit softer. That's what it looks like. And the light in the scene might be a little bit more accurate and might be more performant if I have more than 3 lights. But I only have 3 lights, so deferred rendering actually has a lot of overhead. So I probably don't want to use deferred rendering. And it's probably safe just to say use graphic settings if you don't know what you're doing. Let's use graphic settings there for now. Cool. All right. The same thing with HDR, right? That's type of light. MSAA is screen space anti-aliasing, which is what we're going to see, and as well as dynamic resolution, if you want to use that in there, where some objects appear higher resolution than others. So that is the camera. We'll talk about the camera next week, but it affects the way the light is being seen in the scene. Okay, so these lights, obviously not really needed. Let's get rid of them, but I wanted to explore what those look like. And I talked about the directional light being like the sun. One other thing to notice is there is a lighting panel. Let's bring up the lighting panel. So if I go window, and if I go to rendering, there is something called lighting. So window, rendering, lighting. And it gives me another panel. And I usually put it next to my inspector, where I can look at the scene. Here's my scene, and it talks about my lighting right now. I can also look at things like the environment. If I click on environment, it basically says the skybox material is my default skybox. And my sun source is my directional light. I can change this so I don't have to have a sun source. And if I kind of get rid of this thing, right, then my ambient light, the way that the light comes from everywhere else in the scene, will look a lot different. So that's my sun source gone now. And if you look up in the sky, that little skybox, I'm not getting light that's added to my scene because of my my sun source, my directional light. Let me do that back again. So let me put that back in. So again, I'm just going to point to the directional light in the scene, right? So I can drag and drop the directional light inside this, the sun source. My real-time shadow color is whatever color I've chosen. My source for environmental lighting can be the skybox. I can also make it a gradient or a specific color. Sometimes you don't want to use the skybox, especially if you're inside. If you're an inside scene, there's no need for you to have a skybox at all, right? You want to get rid of the skybox because it actually does some calculations in the scene as well. In fact, what you want to use is a solid color. Chances are black, right, or whatever, or maybe gray if you want to not be as harsh. And then what you can do is you can change that there's no source for environment lighting, or you could choose another source for environment lighting, which is not the skybox. Okay. And so that is there. You can also turn on fog. Fog is a cool effect. And what fog does is farther away in the scene, right, as an example, what it will do is it'll create an area where it's far away like this. It'll seem that there is, it'll be grayed out if the object appears to be far away, right? Why this is good is it reduces the resolution per pixel of an object that's very, very far away, and makes it easier for us to render objects that are close in. It's less computationally expensive to see pixels that are far away as opposed to the ones that are really, really close. So fog is not a bad little technique to kind of turn on. Just be careful, because sometimes what you want to do is you want to make sure that the fog makes sense. If you make the fog really strong and it's all over the place, it can also occlude the way you see your scene. Okay. You can manually generate your lighting, by the way. You can manually do it. And we'll talk about baked lights another day. There's two ways to do things. You can make things, the lights calculate in real time. And you can also have something called baked lighting. For example, if I never want to modify the shadows that are here in the scene at all, then it's more performant to bake these shadows in the scene and then add them in as a post-process, which is what happens when you bake the lights, as opposed to them having real-time lighting. Real-time lighting is great when you have a light that's moving. But if something that's always going to stay static or fixed in the scene, bake it is the rule. Okay? I'm just putting that out there in terms of how it works. So we're not going to bake anything. We're just leave it as is. We're going to go back to our inspector. So that is kind of a very high-level intro to lighting. There's so much more to do. You can add something called light probes to make your scene, to give help how the scene looks, and we might do that later on this semester. And especially when it comes to quality settings, we may adjust the quality settings as we put everything up in mobile. Some of the stuff we can do here in the scene, it won't translate properly to mobile, because mobile uses a different way of rendering 3D graphics than we do with WebGL, or even something like making it for desktop. Now, right now we haven't made it for WebGL, and this is this part now. So we're moved away from lighting. We talked a little bit about it. There's more details that I put inside of the PowerPoint. Please read the PowerPoint to get a better understanding. As well, I've also put some information about lighting inside of the course shell this week. So it talks about lighting in more detail and the different rendering pipelines. Okay, so that is a little bit about lighting, materials, and shaders, just very, very quickly, as well as UV mapping. We covered all those things, and they work both on Blender and on the Unity side. Now what I want to do is I want to move in from lighting, and I want to change our scene so it renders inside of a WebGL web page. Let's do that. All right, so when we go to File, I'm going to go to Build Settings. Again, we're sitting at around 610. We have 20 minutes. We can do this. Notice that my platform, I'm on a PC. My platform is PC, Mac, and Linux standalone. So I went to File, and I want to Build Settings for those people who missed that. This is required for your assignment 1, part 2, by the way. So notice that in the scenes in the build, there's nothing in this, no scenes that have been in the build. So what we can do is we can say add open scenes. Right now we only have one scene called main. This is our main scene, right? And main is basically telling the build settings which scene starts first. We want to tell Unity which scene starts first, and it orders it in an index. So scene 0 is main. If I added other scenes in there, we only have one scene right now. But if I added other scenes in here, think about them as screens on an application, then I could order the scenes inside of this build settings area. So that's the first thing. I'm going to save my project and save my scene. So save my scene, save my project before I move on. Now, I want to change to WebGL. In the beginning, when I asked you guys to download Unity, I asked you to also download WebGL. So please click on WebGL and then click Switch Platform. What this is going to do is it's going to take all of our objects in the scene, textures, it's going to take our models, and it's going to convert them so it's compatible with the web. That's what it's going to do. Okay, so mine, it just did that. Yours might be taking a few more minutes, a few seconds or whatever. but now it's been converted to WebGL. Let's file, save project, just to make sure we saved a couple times so it's taken our build, our changes. By the way, if I put this up on GitHub, because it's not gonna have the library folder, when I load it back in next week, the build target is gonna be the default, PC, Mac, and Linux. I have to retarget or change my build target to WebGL again. Notice the little Unity symbol that indicates which target I'm using. And again, later on, we'll have things like not just Xbox One, but Xbox One Series X, PS5, and so on will appear here later on. But you can't do PS5 or PS4 or Xbox One without a proper license, an API license. And you have to get permission from Microsoft and Sony in order for you to do that. Same thing with the Nintendo Switch and a lot of stuff. You can get additional platforms that you can include here when you have access to do that as a developer. We don't have access right now, so we only have access to the basics. Okay, next. Now we want to do player settings. Under player settings, by the way, this is covered in the PowerPoints a little bit. Under player settings, you can see that the company name is my default company. Let's change this to Centennial College. So again, the way I got that was I went down here to player settings when I'm inside the WebGL build, player settings. Centennial College. Here's my product name, COMP397 W2021 Lesson 1D. That's wrong. It should be Lesson 3A. And it kept that because I never changed it from the first lesson that we did together. The version number is the version of our project. We're leaving that alone. And you can see that there's different builds up here. We're looking at the WebGL build. And by default, I'm in something called resolution and presentation. Right now, my resolution for my build is going to be 960 width by 600 height on a web page. It says run it in the background, and I'm using the default WebGL template. I can also make my own. Right now, we're not going to do that. We're just going to choose the default WebGL template that's going to say made in Unity and all that kind of stuff. Cool. Let's keep going. Other settings is where I want to go next. Other settings talks to me about my gamma or my color space. It's linear or gamma. By default, gamma is the is the color space we want to use for WebGL by default. Auto graphics API, we want to make sure that's checked on. Light map encoding is high quality, right? That's fine. We're going to change these later on. Scroll down here where it says API compatibility level, which is .NET Standard 2.0. We can also choose .NET Standard 4.0. We're not going to do that. That's going to increase. We're going to add additional functionality to our C# coding. We're going to leave that for now as .NET Standard 2.0. Our C++ compiler configuration is release mode. So what happens is the way WebGL works is I take a C++ program because Unity, although it's C#, on the back end it's C++. And it converts, it uses our C# scripting and converts into our native C++ through our high-performance C# script. It converts it to a backend C++ when it actually builds it for PC or Mac or Linux. But when it comes to the web, it converts it, instead of going to C++, it converts it into something that is compatible with the web, which is WebAssembly on the back end and WebGL and JavaScript on the front. All right, and it actually creates an index.html page we can modify later. Okay, so that is nothing to touch there. As you can see, I really didn't touch anything. The only thing I modified was in my resolution and presentation. I didn't change this, but I did change my player information for company name, product name, and I didn't touch version. Yay, save that. And now I want to build and run. So when I go build and run, after I've made those changes, not much, we really didn't do much. If I click build and run, it's going to basically say, where do you want this to go? By convention, we put it inside of a builds folder. Let's do that. So again, new folder, and I'm going to go into builds. And in my builds folder, I'm going to double click inside of there and then click select folder. When I do that, Unity is going to do its dance, and it's going to put my build, my WebGL build, inside of the builds folder. It's going to take some time. It's going to convert some of our textures and everything else so it can work on a web page. Okay. And when we're done, you're going to see that the web page is going to be populated. Unity is going to run a little web server locally on our machine for testing purposes. The next step is we're going to put this up on GitHub. When we put it up on GitHub, we're going to test this thing in its own build. We're going to make it our little own build of this structure. You're going to see how it works, and we can actually put this on GitHub Pages. Now, there's a few steps. I'm going to show you once this week, really quickly, and then I'm going to show you again next week before we publish your game for the first time. So you can see this is taking a bit of time. For you, it might take even longer than this. Why? Because every single time we build with WebGL, it uses something called the IL2 CPP, right? So this is actually converting from C++. We're using that type of compilation engine as opposed to mono, right, which is the default mono behavior. We can't do that with WebGL, but we can do it on PC. Great thing about this is whatever we produce with WebGL, for the most part, should work with mobile devices. Why? Because they both use OpenGL ES from a language perspective when it comes to how we render stuff in the scene. So for the most part, anything you produce with WebGL will also look very similar on a device, which is what we're going to get into in the second half of semester. So you can see it's taking its sweet time to do its thing. And why? Because it takes a while to convert. For those people who are watching the video, and if you have the capability of doing that and you're watching this after the fact, you can certainly skip ahead until you see this little, indicator, this loading indicator, or this compiling indicator is done, right? And then you're going to see the page come up in a few minutes. We have mine, it's done, except it populated in a different spot. Let's bring it into the scene so you can see it. And yeah, look at that. There it is. That's what we're looking at. You can see that this is what it looks like, right? And this is the exact same thing. It's a little jittery because notice that my sensitivity in the scene is way more jittery than I'd like. And the reason for that is because I made my sensitivity, my mouse sensitivity from last week, I made it like 1,000. We can reduce that a whole lot so it's less jittery and a lot more smooth than this, all right? But we wouldn't be able to tell what this is like unless we modify it. And if I go to here and I make this full screen, then you can see now that I can actually get a full screen effect again on the web. This is a web page, my friends. A web page that's generating this. So it looks pretty good for a web page. All right. Nice, nice, nice. Excellent. I want to put this up on GitHub. How do I do this? I want to use something called GitHub Pages. And this is the last piece that I'm going to show you here. So again, I'm going to, now that I've built everything, I'm going to File, Save Project. And I want to stop Unity. All right, so I'm going to turn off Unity for now. And I know it's not perfect, but it's okay. I'm going to go here and view changes. And you see that there's a couple of changes. One is project settings have changed, right? As an example, save all changes. And I'm going to say updated settings for WebGL build. That's what I kind of did locally. I'm going to commit changes. And I'm going to go to push. But however, what you're going to notice is because of my gitignore file, my gitignore ignores the build folder. Okay, it ignores it. So in other words, if I look at my project files, so let's go into my project files, and let's take a look at this thing. I have my file lesson, my lesson 3.8. I have a builds folder that's outside of my assets folder. Right, and inside my builds folder, I have this index.html. And if you double click on this, you're going to think that, well, probably, Unity is going to launch it and everything's going to be fine. And you're going to see that it's going to bring this page that looks like this, and it's going to take forever and probably never load. At least not on Chrome, okay? However, if I open it with Firefox, so if I try it again, double click, or let's say open up this page with Firefox. Let's say I open with, right? And I choose Firefox instead of Chrome. Then a lot of times the old version of Firefox will just run it. But notice you see that something's not right. Something's not running. And the reason for this is because it needs a server in order for me to run WebGL and all this kind of stuff. And I'm not running a little server. I'm just double clicking on the file, and that's not good enough. What I need to do is this builds folder that I have here, I have to put up as a separate project on GitHub. Separate project. So I'm going to show you the quick way to do it so you see the workflow. And then next week, I'm going to go into more details on how to do this. What we need is another Git project inside of the builds folder. All right. So I can push this to GitHub because right now it's not on GitHub. Anything in builds is ignored, right? Yep, you can disable compression and so on, but you shouldn't worry about that. I can actually run it, my little server, by running a little server on the desktop. Like for example, if I brought up a command prompt, then I'll show you this later on this semester. And if I was to navigate to this file here, again in command prompt, so if I go cd space and then I navigate it to the builds folder of my project, right? And then inside of my projects, I say something like light server, then it's going to work just fine, right? Because I'm running a little server that's local, right? So what's going to happen is, at least for the most part, it'll run this. Sometimes it'll stall like this too, but only because it's trying to run locally, and it's doing its best to. It's crawled most of the way, right? But let's see what happens if I bring this into Firefox. Just one sec. Right, so if I open it up in Firefox, a lot of times Firefox responds a lot differently. Sometimes it pauses like this too. This is not broken. This is just because we're not live, and this is a local file that's sitting on my pages. Sometimes also I have a Canary, Chrome Canary, as well as Firefox developer version. A lot of times I like to use those as other options because they have different performance. But you can see that here, even when I'm running my little server, it's not really running. So, but it will run as an example on live. Let's see if this works. At least it should. And the way to test this is to put this up on GitHub. Okay, put this up on GitHub. So I need to put builds on GitHub. Let's use Gitkraken to do that, and then we'll end for the day. So cool. I want to make a new tab, and I want to make start a local repo. And I want to go inside of Centennial, but this time I want to go inside of lesson 3A, right? And I want to select my folder, and my path is going to be builds. Okay, that's the path. So builds that are inside lesson 3A. This is different than what I did before. I do not want a gitignore file. Please do not put a gitignore file here whatsoever. Okay, I don't want that. Then when I click Create Repository. All right, cool. So this is a repository that's inside here. There's 15 changes. I want to stage all these changes. Here we go. And what I want to do is I want to say something like, this is my WebGL build, right? And then commit. That's what this is. And I'm going to put this up on GitHub, just like normal. So I want to say, hey, let's push it to GitHub. It's going to say, do you want a remote? Yes, I do. So now I'm going to make a brand new repository, right? And instead of the repository named builds, I'm going to call this COMP397 W2021 and it's going to be week 3A build. Okay, so this is the build for week 3A, separate, complete repository. And then if I click Create Remote and push local references, then it should work, right? By pushing this up, it's going to take its time. It's going to make its own little repository online, like normal. Now, if it didn't work, it says repo already exists on this account, right? And it's probably because I used the same name, builds, whatever. So that's interesting that it did that, right? It did that. Let's try it again, WebGL build. And let's push it again. And by the way, if you want to look at, we have an origin remote. Let's say this is our origin. I can always remove it. I can remove the origin remote or edit it. Here's our origin remote. Look what it says. It is pulling from W3A build .git. W3A build.git. Let's make it a new name. So we'll say W3 week 3 build as opposed to this. So what we want to do is we can go into the left if we messed up, like we just did. And where it says origin, this one, I can remove it. I can delete it, remove the origin remote altogether. And let's add another one. Let's try it again. Because notice online, if I go to online and if I go to Centennial and if I refresh, you can see that here's the build right here. But somehow it failed to do this build when I did it last time. It said, oh, I don't know what you're talking about. Why is that? Well, because it's GitKraken saw the outside GitHub Git repository, right? So that's why I did this. But nevertheless, it worked. This is not good enough to put on, but it has my index.html in the root of my folder. All right, that's what it has. So this is what I want. What I can do, because this is my build, I can go to settings and I can scroll down to where it shows me GitHub Pages. And GitHub Pages is a way of hosting files for free, sites for free, for every repository you've ever made, as long as it has an index.html that is exposed in the root. And that means in my folder, right, I need to see index.html here. If I don't see it, and if it's inside another folder, this is never going to work. It will never, ever work if I want to try and do this, okay? Well, let's try it again. So I'm going to go to builds, right? I'm going to go to settings, and then down in settings in my GitHub Pages area, I'm going to choose the main branch, and then click Save. And if everything goes well, it may not because of this weird problem we just got from, that I got a message from GitKraken, right? If everything goes well, and when everything is made, if I scroll down here, you're going to see under GitHub Pages a new link called HTTPS centennialcollege.github.io/COMP397 W2021 week 3A build. Okay, so if I go there, if everything goes well, then it would completely build. Notice that it stops in the same place. This is actually live, guys. If you go there right now, it stops in the same spot as I did before. So like we said earlier today, compression is an issue right here. I can't make this work, even if I refresh it, because of this problem that we had. So Liam was talking about that. Liam, thank you for that. Let's fix it and do it one more time, and then we're done for the day. So, but it did go up online, and we're going to fix this problem. One thing to note is, in order for me to correct this, let's just make sure that we don't have an error. I'm going to go to github.com, and let's just get rid of that. We can always get rid of repositories, by the way. So if I go to repository and I want to get rid of a repository, I can go to settings, and I can go to the down. I can scroll all the way down to the danger zone, and I can delete the repository. It's going to ask me, are you sure? I'm going to grab this whole thing here, and then we can delete it. And then it's gone after I put in my password. Okay, so it's gone. So we've gone. We're never going to see it again. But that's okay because we can create it again. And we need to do that because we need to fix the problem that we had in our WebGL build. Let's go back into Unity one more time, and then we're done for the day. So again, I know I'm running a little bit late. Bear with me, and let's see what happens. All right, so again, let's run it. So we're going back in here, and we're going to run it one more time. Yeah, compression is a real issue sometimes. So let's do that. Let's disable that as we go forward. Because otherwise, compression, some browsers, the way it sees things. Let's do it again. So we'll get File, Build Settings, and we're going to go to Player Settings. And on the right, we're under Other Settings, right? If I'm not wrong. You're going to see suppress common warnings, allow unsafe code, use deterministic compilation, enable analyzers, and optimize mesh data. Where was compression, Neil? Where'd you put it? Or Liam? I don't know why I'm calling you Liam. Neil, Liam. It's my fault. So compression is the area, publishing settings. That's right. Sorry, that's here. So code optimization is speed, and what you want to put in is this is the code optimization, right? So let's put size. Size compresses it, right? Speed is what I want. So at the bottom of the player settings. Let's do it again. So again, bottom of the player settings, under publishing settings. Yes, that's right. And compression format gzip, and we just put disabled. So we don't have any compression at all. There we go. Okay, let's see if this works. So I'm going to say save, and let's do it again. And that's nice learning for us, for all of us, including myself. Let's do build and run, because it never used to be that way. If I go build and run, and let's choose the same builds folder, and then click select, it's going to overwrite all the files that were in there before and rebuild our project so it works. Let's try this again one more time. And then hopefully it will allow us to push everything up on GitHub, and then we're good to go and we're done for the day. And so that was much faster. So this is our file, very, very sensitive, like we said before. You know, I'm not really, here's something that I want to share with you too. I'm not really trusting that that change went through. That was way too fast for me. Is this the part of the lab? Yes, it is lean. Yeah. So, so if I go back up to this and I go to builds, one thing I like to do is wipe it out. Just get rid of it. Keep the Git folder if you've already done Git. I don't want to redo Git, but I want to rebuild it from scratch. And instead of doing an incremental build, I'm just going to go build and run. I'm going to choose builds and then click select folder and let it go to do its thing. And the reason why is I'm not trusting that the build was wiped out from last time. It just happened way too fast for my comfort. Like this, that's not happy for me. I remember how long it took last time. That took way longer than that, right? So I mean, compression must have taken a whole pile of time, right? So let us save this. Save. So file, save project. And let's close down Unity again. And let's put this up on using Gitkraken. So Gitkraken, we've got this. We can see that we've got a bunch of stage changes, 8 files that were changed, few changes. These are the files we changed. I'm going to stage all changes and say something like remove compression, commit changed state files. And now let's put that up on push it up again. Now I don't have a remote. I removed it. So I'm just going to make one again. And I'm going to do the same thing. I'm going to go to Centennial College, and where it says build, I'm going to go COMP397 in the winter 2021 semester. But let's just call this week 3 build. So not week 3A, but week 3 build. Still going to give us a problem. But if I click create remote and push references, because we're doing a Git repository and a Git repository, realistically, we should do its own repository in a separate folder. And that's probably why it's giving me these issues. But look, you can see now it worked. Let's take a look at that on GitHub. So there it is. There's my index.html. And let's go to settings, and let's scroll down to where it has our GitHub pages. Let's change this to main and save. And if you give it a minute or so, what's going to happen is it's going to create a new link on GitHub where we can see our build. And okay, so that's the reason why this happens sometimes, because it hasn't propagated yet. That could be the reason. The way to check this again is to go to Centennial. And when you go to Centennial, if you go to the build one day, oh yeah, looks like did I break GitHub? Woohoo! I broke GitHub. I got the unicorn. The unicorn is awesome. If you ever get the unicorn, it means it's not you. It's them, right? I can't break Centennial, right? That's like impossible. That's my whole repository, right? But I can break, something went wrong with GitHub. It was doing something in the background is what I'm saying. Okay, so if I go week 3 builds, notice this little check mark. You can see the check mark in commits. On the commits, if you see a little check mark like this, it talks about how the page was built. It was deployed. And also on the right-hand side, you can see where it says a new thing that we never saw in GitHub is environments, where we see this GitHub Pages thing. So if I click on GitHub Pages and click View Deployment, now if everything was to work, we would see this. Thank you, Liam, right? And we can, gotta say thank you to Liam, because he was the one that helped us with this. And you can see that here we go. we can run around the page, even though it's pretty janky because of the my mouse movement. And we can also make it full screen. There we go. There's full screen. We can move that around, and we're actually doing it live. You can go and test that page out for yourself and check it out. So how do you get to that page? You can go to centennialcollege.github.io. I'll put this in the chat for you guys. So try this out for yourself. Here it is. Try it out. That is available to everybody, right? Now there's some stuff we have to fix still. Like for example, the sensitivity of our mouse is really super high, right? At least for me. So that's something we have to go into Unity and adjust. Right. Cool. I like it. Everything's fantastic. And let's stop this insanity. But now we've done a build. Okay, cool. So let's build up go back to our chat. Are you guys with me? The people that are left, I know there's only 12 of you left, and a lot of people had to go because it was the end of the day. Did you guys get it? Are you guys, wait, okay. Katuk, you got it. I don't know, Liam, did you make yours work finally? Maybe you did, maybe you didn't. Mine works okay. Okay, last bit. And I got to show you this. This is not part of the lab, but the part of the lab that you want is, you wanted that part with Unity. The part in the lab with Unity is when I said capture the screen. Okay, so I didn't need you to put it up on WebGL. I want to show you WebGL, but the part in the lab that was with Unity is deploy or convert to WebGL locally. Going up on GitHub, I don't need you guys to put it up on GitHub. I need you guys to be able to deploy to WebGL. But we have one scene, and this is the last thing I want to show you. I can make a brand new scene. Let's do that really quick. So I want to create a new scene, and we're going to call this start. And I want to take the start scene and put it in my build settings. So here's build settings on start. And I want to put the start scene, notice I dragged and dropped the start scene before my main scene. So it starts with the start scene, then goes to my main scene. Okay, my start scene is pretty empty, right? And if I go to my start scene, it's going to show me this, right? Which looks like this. Okay, so I want to add a button that goes to my new scene, and I'm going to cheat here for a second. We're going to go and do user interfaces later on. So all I want to do is add a new empty object, which I'm going to call game controller. Okay, here's my game controller. I know I'm over, guys. You guys have to go. It's okay. It's going to be recorded. So notice I have my game controller here, and I want to add in a new script. And I want to call this the game controller script. Okay, so right click, and I want to make a new C# script called game controller. And what I want to do is in my game controller script, I want to drag and drop my game controller script on top of my game controller game object, like so. There it is. And if I double click on my game controller script, what I want to do is I want to include something called my scene manager. And for that, you need to use a new using statement using Unity engine dot scene management. So this is the one, by the way, I put this in on the PowerPoint. So if you look at the PowerPoint, and I talked about scenes here later on, so you can see it, right? So I did shadow mapping, and I did shadow cascades, which we talked about in detail, and meshes, materials, and textures on Blender. I did Blender materials, and then I went right down here into WebGL and something called scenes. So I need this. This is required. This using Unity Engine scene management, and the only thing I need is scene manager.load scene and whatever the name of my scene is. Okay. So what I want to do is I can use on GUI. So this is something like a immediate mode UI. So this is built into Unity on GUI. And what on GUI does is it triggers when Unity loads. So I can say something like if GUI dot button, right? And I can say that the position, I can make a new rect. And in Unity, I can put the button on the top left corner somewhere. So let's say something like, I don't know, 10, 10. pixels on the left-hand side of the screen, and the button will be something like, from a width perspective, maybe 100, and it'll be like, I don't know, 30 pixels tall. And what I can do is I can say the name of the button, like for example, we'll call it start. Okay, so if this button has been pressed, is what I'm saying, then what I want to say is, hey, scene manager dot load scene main. And what this is going to do is when the button is pressed, then I'm going to be able to go to the main scene. Okay, so it's a single button that allows me to do that. And it's just to demonstrate, I don't need any of this stuff right now because this little thing that I made is just to make the button go. So the way this works is if I run the game now, going back to Unity, and if I was to, you don't see anything here, there's nothing in the scene except for the game controller. If I press play, and if I did things correctly, then if I did things correctly, which I didn't, then this little function, which is on GUI, right? Let's make sure it is correct. So I'm just going to look it up one sec to make sure it's the correct little tool. So Unity on GUI. What did I miss? Oh, G, capital G, and capital UI. That's all. I just a misnaming of the scene. So it's on GUI, like so. On GUI. There we go. And when I save this thing, when I load it again, I load the scene, then we're going to see a button immediately up here. And if I click start, it's going to take us to the start scene. There we go. And that's what you should see. So you should see that it's going to run just like before, right? Except now we have a start button that's going to appear. So let's now build this to WebGL and put this up on the web as a final version. All right, so file, save project, file, build and run. And now this is going to do is it's going to add another scene, a start scene, and the only thing it's going to have is a little button in the top left corner. It's going to say start, right? And if you click that button, it's going to go into the next scene, and that's how you make multiple scenes, right? We're going to talk about user interfaces at another time. So when you have your user interfaces, as an example that you make with the canvas and all that kind of stuff, you can test them by using the scene manager. Scene manager is a built-in class in Unity, and all we've done is we've said Unity engine.scene management. Once I included that, I included the libraries that are included in the scene manager, and then I can call the scene manager and then say load scene. But the only way that I can load the scene is if it appears in build settings. If I don't have the scene listed in build settings, I can never load it. Okay, so that's how that works. And we're going to wait a second. This is more like it, where I usually expect our WebGL build to take this long, as opposed to like the instant that it took last time when we did this. Right? I was like, wait, how come it only took like not even a minute to do? Now it's taking a little bit longer, and that's what I was expecting. Okay, for the people here, I know there's not a lot of you left, but because I've gone way over, I'm at 15 minutes over the time, plus another 10, let's say 25 minutes over. Anybody have any questions around this stuff before we stop for the day? Because this is all I'm going to do after this, just showing you this little thing. So I know there's a pile here that I've given you today, lots of stuff. We talked about just as a follow-up while this is doing its thing, and I'll just talk about the PowerPoint while it's doing stuff. We discussed a bunch of stuff here. It's finished. Today we talked about Blender, how to start a mesh. Let's pull this in. So there's my new thing, start, and this is the test. So I can still do the same thing I did before, but I just have a little button. I have that little scene that comes up, and the first scene that comes up is not that crazy stuff, but this little start button right here, which I made programmatically. So I didn't have a canvas or anything else, just for testing purposes. So start, and then all of a sudden we're good to go. You can see how sensitive that is, crazy sensitivity, which you want to definitely scale down to, let's say, 100, 10 times less than what it is right now. So we did, we started with a mesh, we downloaded a texture, we built some basic material. We talked about basic materials and textures. We did some UV mapping, brought it into Unity. We ended up talking a little bit about lighting and making sure that it worked in Unity. And then we built WebGL and deployed to GitHub Pages. And now I talked a little bit about scene management, which was very, very simple in the way we did it. So that's what we talked about all this week. Remember that coming up, Wheat Lab 3 is due Saturday, this lab that I've talked about right here. And assignment 1 part 2 is due next week. Let's finish off. Now that we have this, we'll file, save project. And I'll do 2 pushes to GitHub, one for the main project. So if I go back to this, and if I go to COMP397, Winter 2021 Lesson 3A, and I click View Changes, you can see these are the changes. I added a start scene, and I'm going to stage all my changes and say, I'll say something like added simple start scene, right? Commit changes, and I'm going to push. That's just going to push the main project, so nothing to do with my my build. Then if I go to builds, here's my builds, and I can see here I've got 3 file changes. I can view my changes. These are the ones I changed. Stage all changes, and I'll say added start scene, right? Commit changes to 3 files, and then push those up. So 2 different projects, one for the scene, as well as the other one for the project. And when we're good, if I go back to see that scene live, so if I go back to here, and if I go to week 3 build and look at 4 commits, you're going to see there's another check mark here that tells you under the commits that everything is good. And what I can do, if I go back to my project, COMP397, W2021, week 3 build, and if I look down at GitHub Pages and click onto it and go to View Deployment, which is this new one, I should see the empty scene with just a button. Here it is. And if I click the button, then we're good to go. We go into the new scene. So it's a whole new scene after we've clicked that button. Pretty cool. Still really janky, but we're closer and closer to where we want to be, one step at a time. All right, guys. So for the lab, all you really need to do is take that screenshot that we did in Unity of the little pillar that we brought in from Blender, as well as give me a link to your GitHub pages, and that's all I need. All right, so actually your GitHub for this thing. I don't need it to be live on GitHub, but you should have deployed to a build. So take a snapshot, maybe a couple screenshots that show that it's deployed live, and that's all I need you guys to do. So that's it. One thing I'm going to do just for you guys so you can see the build and what it looks like, and what I did is I'm going to go up to 2 things, to my YouTube recordings. I'm going to go over to where it says GitHub repos, and there's 2, right? There's this one, the starter repo for Lab 3, and I'm going to add a new link, and this is the build. So this is week 3 build. And I'm also going to give you the live link so you can see that that is the deployment. So that is up here. When I go to my build and I go to my deployment, my GitHub pages, and I go view deployment, that is a separate link altogether, right? So just to show you that, I'm going to give it to you as well. So new, great link. This is live site. All right, so that's what you'll be doing later on this semester when you'll be asked to, oh, this is in the wrong spot. Well, you'll be asked to put it, to kind of put it up live on GitHub repos. Well, you will be asked to put it live on, a provider of your choice. This is how you would do that. You would put it up on here. So you have really 3 links, right? One of them is going to be your project repository, which is this one. Second one will be your build, test your build. And you need this one in order for you to make your live site. These are 3 different links that you're gonna have to, eventually make. The only one I really care about is your link to your repo and your live site. I really don't care about this middle step. This middle step is for you and for your testing. Okay, that's it for today. That was really long. I know I went over time about let's say 20 minutes plus 30 minutes, let's say. But I did it because I wanted you guys to have everything you need for lab 3 as well as for your assignment 1, part 2. I know there are going to be questions around this one, guys, and I really do appreciate the fact that the people that stuck around and did for as long as you did. Thank you so much. Again, next week, remember, we're going to be talking about cameras, the camera component, perspective versus orthographic projection, near plane versus far plane, back face calling, and something called Cinemachine, which we're going to get to next week. Otherwise, that's it for me, guys. Thank you so much for sticking around. I will see you guys next week, and I'll stop with this on YouTube right now, and I'll ask any questions that whoever's left can ask me here. All right. Thank you so much. All right, guys. I've stopped recording. Thank you so much for